So I want to start off this video series on intermolecular forces with kind of a big picture context, not just of intermolecular forces and sciences, but also with them with regard to the course. Now, with Wake Technical Community College, intermolecular forces is what we kick off Chemistry 2 with. If you're at NC State, you're going to finish up Chemistry 1 with intermolecular forces. Two big reasons we do intermolecular forces at the start at Wake Technical Community College for Chemistry 2 is one, it's more qualitative than quantitative, and so it gives us time as instructors to kind of fill in the gaps or anything you might have forgotten from Chem 1. The other reason we like to do this is that this starts falling what are considered high-level critical thinking questions. What we're going to do is start with some very simple premises and build up more complicated ideas. So when we look at intermolecular forces, there are two things we're looking at. Is one, how do molecules interact with each other? We have ideal gases where the molecules interact, but at some point they become liquids and solids. What about these molecules? Because they're not changing chemically. Gas phase hydrogen looks just like liquid phase or crystal phase hydrogen. What is changing to make this thing go from a non-interacting gas to a liquid to a solid? The second is that if we understand these interactions, can we make predictions about other properties of these materials? And this is going to fall into ideas of viscosity, vapor pressure, surface tension, adhesion, cohesion. There are a lot of ideas that we can derive, or a lot of qualitative trends we expect to see based on intermolecular forces alone. So the whole reason of getting you into intermolecular forces is to get you to stop looking at things as A goes to B and looking at it as A goes to B goes to C. So we start drawing bigger and bigger conclusions. Now, in terms of intermolecular forces, there are several, and this video series is going to talk about the different types of intermolecular forces. So we've got hydrogen bonding, ionic bonding, dipole-dipole, London dispersion forces. You will also find some instructors talk about other forces as well. I try to stick to the ones I think are more common than anything else. So follow the video series through, go through, see what's involved, and then see what you can do in terms of predicting physical parameters and physical properties based off intermolecular forces.